I think we can get started. Welcome, everyone. Let's start with company update.
We got the container for the Xbox. There's a big container in Palmer's back parking lot now. Yeah, we're talking about how to get power for it. I think we're gonna get a generator. The chiller's external from the Xbox, so we need that too. It's just gonna have like two pipes, two like 4-inch pipes, water in, water out, cold water in, hot water out. Order processing is going pretty well. Working on the first Tiny Box Pro with Blackwell. So we built it, but the trays we use for the 5090s don't really work. The trays we use for the 5090s put too much space in between the cards, so the cards were getting up to like 90 degrees. So it's not acceptable. We gotta redo the trays. Um, yeah, if the person who ordered that happens to be in here, should be about another like 2 weeks. Want to make sure all the thermals are good on that. Yeah, and we're talking with AMD about buying. I think we can talk about this. We're talking with AMD about buying slightly broken MI300. So maybe we can buy some slightly broken MI300s. We can sell some affordable uh, inference hardware. We'll have to use TinyGrad. It'll only probably work with a TinyGrad driver. But what's the cheapest we can build a box that runs GLM at like a couple hundred tokens per second? And I'm curious what people would pay for that. Like, would people pay like 100 grand? Would people pay 50 grand for a box that could run GLM at several hundred tokens per second? Yeah, that's kind of it.
We need two continents or just one?
One, I've been texting the guy who sent us the pre-order money. He hasn't gotten back to me yet. What he wants in his box. So, some people have more money than time. Um,
Okay.
yeah, no, we're definitely gonna start with one. Uh, where it is, I'm not really sure we have space for two. No, we build one at a time.
Yeah, I mean, once you build it, supposedly you can move to somewhere else.
That's the idea. Uh, yeah, we have to buy or rent a generator. So we have enough power for it. Yeah, I think we'll start building it out. We'll get racks. We'll bolt them to the floor.
And the expensive GPUs.
Well, that's the other problem. Yeah. This is another reason I hope these slightly broken GPUs come through. We'll have GPUs to put in the box. Right now we kind of don't. Scene took the last two 5090s for
Yeah.
some
Of the whole
complicated.
GPU poor enough.
Well, we have a lot of GPUs. They're just used.
Okay. Great. Anyway, let's move on. This is a reverse order, so we will start with CI updates.
Yeah. So, I mean, the big thing is I split up the benchmarks into many smaller pieces. If you see the metal one fail, especially with that, I like the impacting interactivity warning or whatever, you send a message in like the CI failures channel rather than just rerunning it because for a while I thought I had to fix that, and then I realized it came up again. And it's hard for me to know if it's failed again if you just click rerun. Uh, and then it doesn't show up in the when you scroll through the history that it's failed. But I think that should be fixed. But if it fails again, then I'll look into it a little bit more. And the other big thing that I changed was our CL backend, our CL runtime that we use is now using Mesa's Rustical, which seems to be a lot faster, which is nice. Yeah, I saw that it caused that one issue with the indexing out of bounds.
That's a real bug. We need to fix that anyway.
No, that's a bug in Rustical.
Oh,
I knew about that, but it didn't fail when I ran it, and So I assumed it was deterministic, and that if it didn't fail when I ran it, that was fine. But
Oh, okay.
apparently it's not deterministic. But
Yeah. What's the bug in Rustical? Let's just get it fixed upstream.
yeah,
Are you sure? Are you sure about that?
I'm pretty sure I have an issue opened. I can look at it again. But why do you think that Tinygrad is generating CL code that does actually read out of bounds?
Yeah, so if you see, I don't remember if I put this in my attempt to fix, but I think it's basically generating some form of valid. Then if through read, like just a pointer plus some potentially big number, and I don't think in CL there's a thing saying what's the behavior of that, and compiler can like prefetch that address.
I think you
But-
need
There legitimately is a bug in Rustical where if you index a buffer using a value from another buffer, like it legitimately will read out of bounds, even if you put a guard that you don't necessarily claim that you say like you put it inside an if statement. It will execute both sides of the if statement.
Yeah.
And that's
Yeah.
a real bug.
Yeah, that's I get. I'm just not sure if this valid and drop the clamp on index. It's fine. Looks like it's fine.
I tend to also think like we have check out of bounds. I tend to also think that
No, our check out of bound use that valid. So it assumes when you load, you cannot preload without checking the valid.
yeah, but wait, it's going to totally check the valid. It moves the valid to the load.
It's like a data pointer plus some like 12 gig.
But I have all the clamping logic for that. There's tests for this. I think that it's the Rustical bug.
We have to test for this. Yeah, I mean,
The Rustical bug. It was definitely a Rustical bug, and
okay.
so unless something has changed in the code gen since I looked at it, then I would be surprised if this wasn't their bug.
Sounds good. So what do we do with that? Let's just
We should probably just skip it only for CL. And I'll put a link. I'll change it so it just skips for CL and put a link to the bug tracker for Mesa.
sounds good.
Yeah, those are the big changes. We also Tiny Mesa is added as a dependency, like an extra dependency in that project, which should make it easier for Comma to switch to using IR3 instead of Qualcomm CL. And so that's nice. That's just distributed by PyPy, and I just precompile the wheels and then it just downloads. But if there's some backend, I don't know. It supports Linux, AMD64, and ARM64, and macOS ARM.
Okay.
Yeah.
Any other thoughts to make benchmark faster? I think now the slowest one is the LLM because it beams everything from scratch.
Hello?
Hello?
I can't believe how bad this is. Is it an $8 billion company?
Is it good now? Hello? Hello? Hello?
We can hear you.
Hello?
Hello?
Okay.
Cool.
Okay. I don't know how much people are able to hear what I said, but that's mostly I don't know. Yeah.
Okay. I don't know. I didn't hear anything. Might be my
Oh.
issue.
Oh,
Okay. Well, wait. Can you hear me now?
Yes.
Okay. You didn't hear anything at all that I said?
No. I asked if we can make benchmark faster, and I didn't hear the response.
Oh. Okay. I couldn't hear that. Okay. Yeah. So slowest benchmarks, I think, are the LLM benchmarks.
the LLM for AMD and NV. But I think part of making benchmark faster is just kind of making tinygraph faster at this point. Like it's not the LLM one that's like running Llama and running Quen, like this is not that's a normal thing. But yeah, I mean it's hard to really say that yeah, we have to just speed everything up.
I mean, we could put in stats how long that's taking. That might be useful. The problem is it might be a little bit noisy.
Yeah, I mean it's running Beam too. Like Beam is just really slow.
It's lat and also comma benchmark is slowish.
Well, that's because it's running on a crappy little comma.
Yes. Okay.
Yeah.
I mean, the solution might be just make tinygraph in general faster, but sure.
Yeah. Hopefully some of these. I mean, like Cogen's running symbolic a whole bunch of times now. I think we can get it to a point. Like as things get closer to the spec, we can have pattern matchers that are just kind of always included. Like, because right now we'll do things like we'll run some pass and then we'll run symbolic, and like if we run that pass with symbolic, I think it'll just be faster.
Okay. Sounds good. Yeah, I mean, other than that, I certainly benefit from regular CI being a lot faster, so that's pretty nice.
Yeah.
That
Yeah.
also costs me using my fork less because it's faster if I just open the PR.
Yeah.
Cool. Anything else? What are we going to work on next?
Probably this week gonna try and refactor D-type T-comp. Yeah, that's kind of messy and severe and
Yeah, I think with that you should also do slice removal.
Oh.
So we have a thing called slice that is a combination of shrink and bitcast. It used to be buffer view, but there's no reason it shouldn't just be shrink and bitcast, and I think it's actually really related to the D-type thing.
Sure.
It's the same basic idea, right? You want to
Yeah.
like you're changing your D types, and that should just kind of be okay, and it should all just have normal shape semantics. You also with this probably have to consider the bitcast. It's a little annoying about how you want to deal with the ones.
Yeah.
I think, yeah, so if you bitcast from like, like something that's like 2 uint16s down to 1 uint32, should the shape be, 0 rank or 1 rank?
Yeah.
Oh, I don't have an obvious answer.
Yeah.
I think it's just kind of where it works the best.
Yeah.
Yeah, it's probably 1 rank. You're probably matching torch probably makes the most sense, but or match jacks. So jacks is always good.
I think you will also encounter annoying things in split store. When you try to,
What split store?
so I attempt to remove ops slice with shrink. There are just some intermediate representation that's slightly annoying.
Yeah. Oh, I see. Yeah, I cleaned this up a little bit. I mean, it's better than it used to
Every time
be.
you see there's a like up that is up that slice to a spatial case, you know there will be issue.
Yeah. Well, no, I mean that's been the whole CodeGen project. It's just there's no more really special cases anymore for movement ops. And when all the special cases for movement ops are completely gone, including we need to support load without index. Like right now, we insist that load be indexed, but you shouldn't need an index.
Then how do you know where you are loading from?
The whole buffer. Right? Like think about what the semantics of that in C, right? Like what if you indexing 0 is basically the same thing as like what if you have a buffer that's just size 1 and you index 0? Doesn't really do anything.
Mhm.
But it should be pretty good with that. Like I refactored the renderers to generate the size of the load is a function of the load, not a function of the movement op. Oh, that was pretty good. Yeah, recasts, types.
Okay.
And then the thing that we always talk about, which is ops. They support op.
Oh, great. Yeah. Yeah. I'll gotta figure out what to do about the load cast.
Okay. Sounds good. Let's move on. Next is HCQ2.
So this week I merged the rewrite. So as I said, we have two explicit passes like the schedule and link. Schedule is a lot cleaner now, and it also has cache. So the Python speed is a lot better. So I'm still working on adding cache to the link stage. So basically the current plan is to there is now there is a special pass that can decide if we just wanna do patches during link time, like in Python, or just runtime. So I think for Git I'll do link time. And like for like regular kernels, it will be in runtime. So like the C program will just fill up the comment buffer, and yeah, basically that's it for HCQ backends.
Yeah, so the code looks pretty clean. I'm looking at HCQ2.py. Do we have an idea on how it compares in line count to the old HCQ stuff?
It's a lot better. Since this file is the replacement for like HCQ2, or I mean HCQ.py and the graph, I think it's at least 200 line less, maybe 300.
Yeah, I mean, do we have a way for this to support metal? Like, is it clear how it's going to support metal?
Yeah. Yeah, so basically we have the custom function submit, which have with so sources of each are like HCQIR, like the program, or some like wait instructions and dependencies. So yeah, and just for metal, we just will build the C function with UOps, which can just call this metal. I mean, C functions, basically, like the metal C functions.
Well, yeah, it definitely seems faster too. I just ran it. Usually HCQ2 is really slow. I'm not sure what
Yeah,
changed.
so and I've trained like CFAR, it works. I mean, it works correctly. So the only thing to fix is the HCQ link. So just to add cache there, because currently just resolve all the patches, like for copies and for small kernels.
Oh, I see a ton of stuff. I'm looking at an HCQ commit, and I see a ton of stuff. I also see like usage of like shrink, where I think it should be index. I think it's really important to make sure that all these things are like following the spec. That happens to be allowed because of broadcasting. Those shrinks should really be an index, I think.
Yeah, yeah, that makes sense. Yeah.
Yeah, and I wonder how many other things there are like that. Like I would spend time to really make sure that all of this HEQ stuff is following the spec for the UOPS and not just happening to work. What I found is the more we stick to the spec, like the easier it just becomes to reason about rewrite rules. Oh, I see. Yeah. So I'm looking at the input and it's shrink, and then at some point it's getting rewritten to index. Cool. Yeah, I like that it's going through the normal code gen path. Interesting. I mean, I also see a ton of, maybe it has to be this way. Like, why are those not load right? Or why are those not long writes? Like, why is data 7.6? Yeah.
Yeah, basically because like the AMD, like the PM4 is like word size is like 32 bits, so it just builds. I mean, it just builds
I see.
with these parts. Yeah.
Yeah. D-type on decomp. Right. Yeah, no, that totally makes sense from the HCQ perspective. Yeah, and then we can like decomp that later to have that become a single store. We can look for that pattern. But cool, yeah. Seems good. We still on track for this sprint to have this merged?
Yeah.
It's fine to have both too. Like I wouldn't make deleting HCQ a complete prerequisite for this. It's okay if like some of them are HCQ2, some of them are HCQ when we finish the migration with it in master. Because what's annoying now, I imagine, is I don't think this stuff is this stuff tested now?
Not really. Yeah. I mean, I have
How
some like unit tests, but yeah.
Yeah, but if they're not running
And
CI, right? Like, how often do my code gen changes break this for you?
I mean, twice.
Twice, okay.
But yeah, I need to think like how to change the mock GPU to run this.
Cool. Yeah, is there any reason the mock GPU shouldn't run this? I mean, it should all be at like a lower level of abstraction than this, right?
I'll think about that, but I'm not sure it works right now.
See. I mean, this
Yeah,
is
because it.
go ahead.
Yeah. Yeah, it doesn't work because it just intersects doorbell rings with tracking memory views and these things. Yeah.
Maybe what you can do is run the submit with the Python backend in the mock.
Yeah, probably, yeah.
Yeah, I think that would work, right? Because it's hard to actually intercept real C things. But if we just run that with a different backend, right? That's a cool test as well. Run that with a backend where we can intercept. We should also update just for readability purposes. I imagine those things are the actual addresses, those big negative numbers.
But actually, no. I mean, I have YOP from buffer, which can create in YOP from the like buffer class, and that's just the ID to not make them unique. And just
it's the Python ID.
yeah.
See. I mean, in theory, I could imagine the slot of the buffer being the memory address if it's allocated. I don't know, maybe that doesn't work. But I also see get adder is taking a device name. Why is that?
I don't know. We're I think initially because I mean we can have like, for example, buffers allocated on the AMD, and I mean basically like to map buffers from one device, which is like buffer from one device, we can get the address of this buffer on the another device. That makes sense.
Yeah, I think there's a bit more to think through here. Like is there a clear spec for what get adder is?
So it basically should return like uint64 when resolved.
I see you did add it to the spec, or it's in the spec. Get adder. Lower buff to its address on device dev. On device dev, just in case we have to do like address translation?
Yeah. Or just mapping, like here we have the CPU buffer and like this buffer allocated on the CPU, and we just get the buffer on the AMD. So like we can use it, like the GPU can use it.
Oh,
So
interesting. Yeah.
actually,
I see. So that get adder is effectively just making sure it's
like the
mapped.
mapping. Yeah.
Yeah, making sure it's mapped on the GPU at that address. So then get adder then is the return device type? The return device type is still CPU though.
So what do you mean return device type?
Dot device on that UOP is still CPU.
I should fix that. Yeah.
Yeah, it also doesn't have a I assume you want it to move to ALU. Like it doesn't have a so that's the green square means that the adder space is global. I assume
Yeah.
get adder is kind of like a
Yeah.
load. I mean, it's interesting. It's not like this is just like the more that we stick to the spec, the easier this will all be to like just write later and make things work. Because I found that we've done like so much thrashing in TinyGrid's history because we didn't have a clear spec for things. And then you change one thing and then it doesn't work. But you know, I don't mean to particularly nitpick about this. Seems like pretty good progress. Yeah, excited to have it merged.
Sounds good. Anything else?
No.
Let's move on. Next is my stuff. I did bunch of cleanups. I removed ops device, and after they're just thing, I also removed not remove, but like I remove the contract and enroll. I have list. So I want to bring back requires grad. I think let's.
Yeah, so I read this. I didn't totally understand.
So basically, we previously said we can remove it because there's no issue letting these threads hang around even if like no one uses it. So the bug from the cross schedule thing is if your current sync destroys some tensor, you want all other tensors not in this sync, but depends on the thing you are going to destroy schedule before this sync. So you want to pull those in.
Yeah, but we should be able to do this using like the tensor machinery. I'm not sure we have to bring requires grad back, right?
So the issue is this mechanism will also realize the dangling grad even if it has no other reader, just because it exists. Because those grads, because we are with every update, we are going to update the model weight, and the grad depends on previous version of the model weight.
Yes.
So if our logic is every time our sync is going to destroy something, also schedule everything that depends on it, then we will also schedule the grad even if there's no consumer for the.
Wait, but it totally shouldn't do that. We
How can you
shouldn't.
tell the difference between the two cases?
Like apply map to tensor shouldn't trigger any realizes. It just moves. It just makes sure that like the buffers stay up to date.
So how do you fix if your current sync is going to destroy some or overwrite some tensor or buffer, and you have some other hanging lazy other sync that depends on the old version of that buffer? So the crux of that bug, the reuse seed, it's because the old version of the seed, some other random rent depends on that. So we cannot just run the later one first without running the first one.
I don't follow that.
So you have a random seed 0,
Okay.
and you have random seed 1, and
Okay.
you have your tensor 0 that depends on seed 0, and tensor 1 that depends on seed 1.
Okay.
So now both tensor 0 and tensor 1 are lazy.
Okay.
So if you realize tensor 0, then realize tensor 1 is fine because the seed got updated correctly.
Yeah, if you're in the other order, it'll be different, sure. I mean, that's.
So that's not fine, I think.
I mean, yeah, this. I don't exactly know how this relates to requires grad. Yes, this is a known problem. Obviously, if you like
Okay,
your
so now,
realization order.
so I think the ideal or the properties that we try very hard to maintain on these assigned stuff is your output should be the same as if you eagerly realize every line.
I don't think we can always enforce that, right?
We can certainly always enforce that.
Well, no, but like if you have a buffer, right? Whenever you have an actual buffer, like that buffer can always change underneath you.
Sure.
And we kind of just accept that?
What do you mean?
I mean, the other choice that we could do is we could just invalidate the graph. Like, if you have that situation that you're talking about with the random seeds, we could just make it so that if you do the second realize before the first realize and you try to do the first realize, it just says sorry. Like, this is stale.
Probably fine.
Yeah, I mean, I don't exactly know. Like my concern with bringing back requires grad to deal with this is this seems like a generic problem that we have to deal with that isn't specific to the grad.
I think it's pretty specific to the grid. I'm fine. I'm probably also fine to just raise and say this is like stale. You should not do it. The problem is that has some usability issue. Now you need to know the internal folder of things.
I would prefer to raise for this if we could detect it. I mean, this is a universal problem, right? Like you can fix this with requires graph,
Well,
but
I would imagine the way to fix this is to go through old tensors and making sure when you are going to write in like overwrite something, making sure everything that depends on it is in this sync, otherwise just raise some
Yeah.
version of that.
that seems right.
Okay.
Like we have some, it's the thing you always want. It's buffer generations.
Buffer generation, buffer version, something like that.
Buffer version, yeah. We stick like basically a version on the buffer, and then that version gets updated when the buffer's updated, and then we see if you're trying to realize a graph that still has the old buffer version baked into it. Like we have a pass called like validate buffers, right? So like you can put the buffer version in the graph in the UUP graph, right? And then when you actually go to realize that UUP graph, it checks to make sure the buffer version actually matches the version of the real buffer. And if it doesn't, it raises.
Okay, sounds good. I need to think more about just how easy it is to raise, but raising it sounds good.
Yeah, I think we have to. I like that as like a behavioral invariant. Like we can't always promise that it's going to be the same as ego realization, but we can raise if it's not.
Yeah, that sounds good. Because the only annoying path is you don't know and things just suddenly goes wrong.
Yeah.
Okay. So I think I'm also. Oh, I also see your change to the allow broadcasting. That's probably something I can work on.
Oh yeah, we should be able to start doing broadcasting everywhere. Yeah. So broadcasting is required in the new expander. The new expander is now 5 lines, and the reason it's 5 lines is because it just uses broadcasting.
Yeah.
Oh, the other thing I kind of want to talk about broadcasting quickly is like, so like I changed reduce to remove the ones.
Mhm.
But we could also change reduce to, instead of taking a list of axes, we could have it only remove axes from the left side. And then just take a count.
Is there a specific benefit? I think
Well,
these two are equivalent. So
the thing that then becomes interesting, I agree that they're equivalent. I think that the count one is more restrictive, which is good. And then we can also start thinking about writing expand like that. So instead of expand turning ones into like a bigger shape, we could have expand just insert dimensions on the left-hand side that are the expanded dimensions.
yeah, so I really want that as at least as a high level API. We currently don't have that.
Well, no, but I think we might want it to be the low-level API. Like the high-level API, we can make whatever, insert some extra movement ops, who cares? But the advantages to making that the low-level movement op is now expand is the exact opposite of reduce, right? So if I have like expand, insert 3 axes on the left, and then I have reduce with 3, it removes those.
Yeah, in principle, that sounds pretty good.
Yeah, I'm quite interested in doing it, and I feel like
Any constraint that's bad?
well, it adds movement ops and it adds some permutes. It adds some permutes, but it removes some reshapes.
Why do you have permute?
Because if you want to expand like a middle axis, right? You
Uh-huh.
have to expand and insert the axes on the left, and then you have to permute them to put them in the place you want.
Huh?
Think about like the convolution construction, right? So like for the convolutions right now, like you have to like expand the height and width dimension to go through the whole thing. So we first do a reshape where we add ones next to the height and width dimension, and then we do an expand, which turns those ones into the height and width.
Uh-huh.
The alternative would be expand, where we insert the height and the width on the left, and then we permute them to put them in the right place. So then we follow it up with a reshape, which puts them together. Overall, I think it would create a few more movement ops, but there'd be less reshapes, and it's just an overall simpler thing to understand, right? Because right now we have expand. It's like, what does it mean to insert the dimension in the middle? It doesn't really mean anything. It's effectively just a copy where we insert the number. I kind of like this, everything happens on the left-hand side thing, right? Like stack adds a dimension on the left-hand side. Index removes one. Expand inserts dimensions on the left-hand side. Reduce removes them.
Yeah.
I'll play with it. I'm just curious if you see a major problem.
I think overall permute is prefer than reshape because reshape is too free.
Reshape is what?
Reshape is very free in terms of spec and the space that you can construct with it.
Yeah, reshape is the most annoying thing to deal with.
Yes. So if it's just some reshape becomes some permute, the sum's not too bad.
Yeah, right now, almost everywhere we use expand, we have this pattern where we first reshape to add ones.
Yes.
And reshaping to add ones isn't really a real reshape, but we don't really, we use it like a reshape, and then you have to treat it like a reshape. That could be the most awful reshape ever when you reshape a tensor that's 67 by 66 into 66 by 67.
Yes. Okay.
Okay, yeah, I'll play with it.
Note. Okay. I digress a little bit. We can use that as a gateway to move on to the new cogen.
Yeah, I changed. So yeah, I changed the reduce to remove the ones. I got to update the spec. Two cogens merged. It overall worked out to be about a 100 line reduction, like a real 100 line reduction. And removal of tons of ops. No more unroll, contract. You remove the last ones on the tensor cores. JEP is gone. JEP is just index. Got rid of VCAT and the other stupid one that I can't even remember. All this stuff is just kind of nonsense. The new expander and devectorizer are quite simple. I mean, the thing that actually took me a long time wasn't rewriting the expander and the devectorizer. Those were pretty easy. The annoying part was two things. One, the old devectorizer conflated two issues. It conflated the devectorization of ALU ops with the coalescing of loads. So first I just did a big refactor where I moved all load coalescing and image stuff to after the devectorizer. And that was a lot easier to write. And then the other thing that was annoying was just the fusion of tensor cores. So we have these tensor cores where the tensor core WAMA instruction supports an accumulation as well as the multiply. But that accumulation is done in a vector D type. Or not a vector D type, but that accumulation is done on a shape, which is different from the rest of everything in GPU. So you can't really use the devectorizer. So that's actually still not perfect. There's still a few times when the thing isn't really fusing into the accumulator. And it was there before. It's just not a regression. But yeah, there's a little bit of annoyance there. But overall, I think there's just a lot more cleanups to do. I can finally remove all of that, rewrite into new style stuff. We have that thing in index that needs to be removed with pointer D type. I think that's the last major blocker from just getting rid of pointer D type. Pointer D type can go. D type vec, the only place it's still really used is x86. So I've got to deal with that. And then after D type vec and pointer D type are removed, I think we could actually just remove D type entirely from the UOP. So hopefully that'll happen. I think this week's aggressive on that, but I think this week it's actually plausible to get rid of vec or pointer D type. And then add some assertions to say where the types don't match. So where the D type doesn't match the I'll write the production rules and I'll just add checks.
Sounds good. It certainly feels nice to remove the ops that I never understood, and now I don't need to understand. Oh, that's great.
They were nonsense. They were just, you know, I read this thing about like coding is not this process of writing code. Coding is this process of developing like a language. Like we're developing a language to talk about this kind of stuff. And I think that the unification of lanes with like buffers is something that doesn't exist anywhere. Everything keeps these separate concepts. There's separate concepts in LVM. There's separate concepts in CUDA. There's separate concepts in C. But there's no reason for them to be. It's the same idea. Like we effectively had two entire shape systems. And then what those ops were that you didn't understand were like crappy movement ops. They were like movement ops that weren't real movement ops, that only applied on lanes. And like C has all of this too. So, you know, now we're moving beyond the state of the art in doing that.
Great. Always feel good to do that. And with that, let's move on to Llama schedule. How fast are we now?
My best run, I showed here, is 2 hours and 23 minutes and 11 seconds.
Great.
Last week we were at 2 hours and 37 minutes. So yeah.
How much time did we lose last time?
We were at 2 hours and 37. So we lost
We're
like 15.
2 hours 37. How about before that? Like how much time are we losing a week? And what does the derivative of that look like?
We're losing about 15 a week.
And this
15
has
minutes.
continued.
Last like 2 weeks ago we were at 2 hours and 50. So yeah.
Nice. All right. Let's keep it up. But when are we going to be at 0?
All right. So I'll share the screenshot. It's clear where we're messing up. If you see this a little bit, zoom out to the end, you see that AMD is idle and SDMA is active,
Yeah.
and AMD is just sitting doing nothing. So it's interesting. I found a bug last week where we were all reducing about 200 times. We have 8 buffers that we need to idle reduce, but we are reducing about 200 times because like we were slicing them. So I fixed it. The way I fixed it was I moved everything to the end. So I do a very big all reduce. Like I'll reduce a buffer that's 900 megabytes. And I'm copying that over like 60 gigabytes a second to the other GPU.
Oh,
So yeah.
because we're stacking the tensor together, we can't overlap the communication with the backward pass.
Exactly. That's the problem. We can,
yeah.
but it's not gonna work. So I'll share this other fun thing because this I tried it today. Gray is if you overlap SDMAs, like you do a bunch of small SDMAs and you overlap them with the backward. So you do it like this. This is how it looks like in the viz. And like if you benchmark this is fast. But like you see like this is doing a bunch of like small SDMAs and it's like
Yeah.
nicely overlapped. So it looks nice, but it's terrible.
Well, it
'Cause I
looks
have
like
all this pressure.
spiky. It looks like it's sometimes faster, but then it spikes up.
Exactly, so it's spiky. That's
Yeah,
the term.
why is it spiky?
No idea, but I've just observed this. This is an empirical.
Interesting. But yeah, no, I mean, we have to do it this way. We have to do it with the small ones because we have to overlap that.
I'm trying to like find a sweet spot where I can like do it small enough, but not too small that it gets spiky. I don't know the root cause of the spikiness. I don't think I
Yeah,
have the tools to debug that.
I would root cause the spikiness, and then we could figure out, like, because, yeah, I mean, this may be something we can fix in our driver, or maybe HQ2 fixes it. There's no fundamental reason that it should be spiky. Right? This might just
Interesting.
be literally like a dispatch issue. But yeah, I mean the small kernels are definitely more correct than the big ones at the end. We can't do the big ones at the end. We have to do it incrementally. We got to make sure it's nice while we do that.
Hmm.
Yeah, only root cause the spikiness. All right, so if we're losing 15 minutes a week, in 10 weeks it will be 0 time.
Well, we gotta get to the baseline with AMD. I think after this, after I fix the spikiness, we'll get to the baseline because we're at 1.52 and they are at 1.3, 1.4 ish. So yeah, we need
mean,
like
yeah.
2 hours first.
Yeah. I mean, then it'll just be a question of good. I think we'll be perfectly lined up to start deleting our to start rewriting the kernels in our stuff, or to push the kernels beyond what they're doing once we get rid of all these once we're at the baseline. We're
I'm
just
still
gonna
working on a branch. Yeah,
we're gonna
I'm still
comfortably be
working on a branch. I'll try to like get to baseline and then merge things into master in a clean way and high level way. Yeah.
Yeah, Nimmeljen, do you have any ideas what the spikiness is?
Yeah, so basically, I think you can check. There is so basically when there is weight, you just need to load some memory, and this 4 is like the delay, like how many. I mean, it's something related to the clocks of the GPU, like how many, like 4 multiplied by some value, I think 250 clocks or something like that. You should wait. So there is similar for PM4. So no, if you like have a lot of small dependencies and they just fighting for the same signal, so it can be just thrashing.
How do we fix this?
I know we can try like to change this value and see if it's like has any impact on the result, and if yes, I think we can think about that.
Yeah. Crosland, maybe the idea is to get a small reproduction of this.
More reproduction. I'll try. Yeah, I'll try.
Yeah. Because I mean, I think this is definitely a driver issue, right? Because there shouldn't be like no consistent kernel should cause spikiness. Also, why are the steps fast at the beginning and then they get slow? Is that thermals?
Oh yeah, I think that's thermals.
It's not thermal.
Like our gems, it gets fat. It gets slower.
What was better? It's not thermals?
No, last time this behavior is known, at least to me, and I posted about it in the channel when I was doing 8B runs. It's the GPUs are power limiting.
That's probably thermals, right?
At least it's not thermal throttling. It's power throttling.
Interesting. Why would that get like what's like the real time on this? Like we put like real time on the x-axis. Like so it looks like there's like 10% more speed if we can figure out how to make it not do that.
Yeah, I mean you'll see it start throttling within like the first 50 steps or like a couple minutes.
This has to be thermals then. Which doesn't make any sense. What's doing this? If it's not thermals, like I mean we know the clocks. Are the clocks getting slower? Can we just add clocks to this graph? But yeah, I know we can talk about this later. But yeah, either way, it looks
I can track it down. Yeah.
yeah, cool. It looks like in addition to the spikes, it looks like there's another free 10% somewhere. That's just the GPU slowing down for no reason. If it's thermals, I will go get bigger fans.
So the one
I'll track it down
concern
with some
I
AMD SMI or something.
the one concern I have for the fast runs, you're converging a little fast.
Why is that a concern?
And it's faster than RCP.
What's RCP?
RCP is the eval step after the one that these runs are ending at.
Is this a bad thing? Is this valid or not valid?
These are
It's not valid if it's faster than RCP. They'll probably just normalize it. So I think when we compare these, it's probably more meaningful to compare per step or something with a fixed steps.
Yeah, it seems fine. Like it seems like we're still doing the right thing. We're making it faster, regardless of like we can figure out like where we actually stand for the real submission. But yeah, I mean, I want to clean up these spikes, do the backwards pass correctly, and then figure out what this throttling is because MLPerf doesn't care how big a fan I get. I have big fans. I have very large fans. I will go get them.
One note I will add on the step, since was Parrot also mentioned, it sometimes converges in more steps, which is like more absolute time. So I only compare when these step times are exactly the same, like the step count is exactly the same.
Yeah,
But yeah, sometimes it just takes more steps for whatever
just worry
reason.
about step time. Don't worry about the other thing. Like step time and correctness. We'll deal with this.
Yeah, my target is pretty much step time 1.38, 1.4 by end of sprint. Yeah, we're like wasting 60 milliseconds on just SDMA that makes GPUs makes compute idle. So I think once I figure out a fix for that, should be better. Yeah, that's all for me.
Okay.
One last thing I'll add. Sorry. I know George, you were complaining about the labels on the nodes in this, like
Yeah.
the indexes are rendering, right? Like it would really help if you can like share the repro.
Yeah. I'll now that new cogen's merged, I'll have some real repros today.
Yeah, thanks.
Okay. Next, GPT OSS.
Has AMD responded?
Oh yeah, no, we're fine with GPT-OSS. Yeah, they're gonna rewrite the contract.
So we have a working forward backward, and then I have a working training step in my thing, in my PR. But you have to have the layers really low and the sequence length really low. So we're missing flash attention and gem. So our existing flash attention doesn't work because GPT OSS doesn't use head dim 128. It uses head dim 64. And it also has an attention sync.
How hard is it to fix this? I mean, the gem I'm not that worried about because that's just speed. But for flash attention, we got to fix the
I need to look into the flash attention still. And then gem is a little more annoying. For MOE training, you really want a grouped gem.
I see. I mean, I just want to get something trained as soon as we possibly can. Like we gotta with the correct sequence length. Like, we gotta fix the flash attention.
Yeah.
Yeah. So this is from AMD. We're good on GPT OSS. It's definitely happening. It's just a question of what times they're going to give us. But, we'll see.
Yeah, for MOE pre-training, you really want a grouped gem, or else you're running a lot of extra gem compute. Because you'll be running the experts even for tokens that don't need the experts, and you just mask them out.
I see. Yeah, I'm a lot more confident in our code gen starting to work for gem than I am for flash attention. Like, I think our code gen could start to work for a group gem. It'd be fast for a group gem somewhat soon. I don't see it being fast for. So it's just that we got to update it to work for 64 and not 128.
And support the attention sync.
What's attention sync?
They add an extra term into the softmax so that because they also use sliding window attention. Every even layer is sliding window attention, not full.
I see.
And then your attention sync essentially becomes a global token that the sliding window can store information in.
Do you have a eval script? In the sense that I understand that training will probably out of frame, but I would expect since we have the model, it should eval a train model and give the correct eval number.
As far as I know, they don't have a published model, but we should be able to use whatever one that OpenAI published.
I mean, it doesn't need to be like a fully trained model. I'm just curious since when you train, you also need to eval. Do we have anything that shows the model works? Kind of.
I mean, you can run the model file and it runs the forward backward pass. It works like how Flat Llama does.
Okay.
No, but yeah, we got to get eval. Let's just get it on the real model.
Yeah.
Make sure it's correct.
Yeah, I think this is similar to all our previous MLPerf. We will have the model implementation and we have eval to make sure the implementation is correct. And then there's like training that follows.
Overall, this benchmark is pretty bad from MLPerf's side. There's a lot of information that's just missing in the reference implementation.
I see. Okay. I think just generally working towards the full thing while think about like how to make sure the steps are correct, and if we foresee issues, we want to know the issues earlier than later so we can like prioritize accordingly.
Yep.
Cool. Okay. We're slightly out of time already. Do we have any issue with comma? Are comma happy?
No, as far as I know, they're happy. I gotta double check that they actually bumped us. But they have a good incentive too because we gave them more performance. So yeah.
Great. And there's some work on GLM and some work on RDNA. No, RDNA. The RDNA assembly thingy.
Yeah, I think that's the RDNA assembly bounty's coming along nicely. I see Rain in the meeting. Yeah, I think maybe next week if you want to talk about that, hopefully we'll be at a point where the tests are passing. So that's cool. And Comma is happy with the GLM we have stood up. Just gonna make sure it stays stable. But yeah, they've all been using it. We have like chat.comma.life now. And there's a ban inside Comma on paying Anthropic any money. So
Sounds good. Anything else for the meeting?
I don't think so.
Okay, that's it for this one. Thank you. See you next week. Bye bye.
Bye.